Abdul Rahman. So before going to the topic, we can have to study the second system. So I have already shared the already that examination you have to study the fourth. Examination based upon the entire.
സാറേ റേഞ്ച് ഇല്ല, ക്ലിയർ ആവുന്നില്ല.
Hello.
സാർ ക്ലിയർ ആവുന്നില്ല. വോയിസും വീഡിയോ ഒക്കെ ബ്രേക്ക് ആണ്.
Okay, so is it audible now?
Yes, sir.
Okay, so I'll be repeat once again what I have told with you. So I have given some information about the second internal examination. So for the second internal examination, you have to study the second and third module. That is the PN junction diode and the bipolar junction transistor. So I have already shared the slide that is recorded to you and already given the test book that you have to follow. And if somebody has to, or if I have to conduct a retest for some students, they have to study the entire syllabus. That is from first module to fourth module. So I think that now that confusion is over.
സാർ റീടെസ്റ്റ് ബെസ്റ്റ് ഓഫ് 2 മാർക്സ് അല്ലേ എടുക്കാം?
അല്ല, റീടെസ്റ്റ് എന്ന് പറഞ്ഞാൽ ഇൻ കേസ്, അതായത് നിങ്ങൾ മസ്റ്റ് ആയിട്ട് സെക്കൻഡ് ഇന്റേണലും തേർഡ് ഫസ്റ്റ് ഇന്റേണലും എഴുതണം. എന്തെങ്കിലും കാരണത്താൽ ചില കുട്ടികൾക്ക് ഇപ്പം നടത്തേണ്ട വന്നു കഴിഞ്ഞാൽ, okay, because of some medical reason or something. But as per the, please remember that as per the regulation, that is also not allowed. Okay, so If we are conducting, sometimes the students may have some other events related to sports or arts during the examination time, then university is saying that you have to conduct a retest. But at that time also, it will be like that. Okay.
മാർക്ക് കുറഞ്ഞവർക്ക് റീടെസ്റ്റ് ഉണ്ടോ?
എന്തോ
മാർക്ക് കുറഞ്ഞവർക്ക് റീടെസ്റ്റ് ഉണ്ടോ?
അല്ലാതെ മാർക്ക് കുറഞ്ഞാൽ നമുക്ക് മാർക്ക് ഇട്ട് കഴിഞ്ഞാലേ അറിയാവുള്ളൂ. Okay. So after that we can decide. പക്ഷേ ഫസ്റ്റ് ഇന്റേണലിൽ അധികം മാർക്ക് കുറഞ്ഞായിട്ട് എനിക്ക് തോന്നുന്നില്ല. സെക്കൻഡ് ഇന്റേണലിൽ ശരിക്കും പഠിക്കുക. Okay, so I think that we can start the fourth module. Okay, if any problem with the voice or video or any doubt, you can ask immediately. Okay, so what I am, is it is visible? So I have shared the slide to you.
സ്ക്രീൻ ഷെയർ ആയിട്ടില്ല സർ.
Hello?
സ്ക്രീൻ ഷെയർ ആയിട്ടില്ല.
Screen is visible.
No, your video is visible, but there is no screen.
Okay, so sorry, I'll be share that once again. Okay. Okay, so I think that now it is visible to you. Okay, so what I'm going to do is that in this class, basically, we will be start the fourth module, that is the field effect transistor. So what are the prerequisites or what are the information that you need to study this module is just the working of the transistor, because basically you know what is a capacitor. So you can see in a capacitor what you are having is that we are having two metal plate separated by a distance. So here what you are having is that basically you can see it is a metal oxide metal contact. So just to see that the capacitor what we are pulling or what you have already studied is something like this, metal oxide metal contact. But here whenever we are coming to the field effect transistor, basically we are first discussing about the MOSFET. Okay. So before coming to this topic MOSFET, we can discuss about this important portion, MOSFET. So here you can see what you are having is that you are having a metal oxide and semiconductor. So just to compare these two, so here you can see that you are having a metal oxide metal contact, but what you are having is that in MOSFET what you are having is that you are having a metal and then you are having an insulating layer similar to the capacitor, that is normally an oxide layer. So this will be the metal portion, and then metal, then oxide, and then you are having a semiconductor. So it may be a p-type or n-type depending upon the requirement or what you are selecting. So this is the MOS structure, that is metal oxide semiconductor structure.
സർ
ഹലോ,
അത് ഓക്സൈഡിന് പകരം പോളാർ ആയിട്ടുള്ള വേറെ ഏത് മെറ്റൽ വെച്ചാലും
ഏത് മെറ്റീരിയൽ വേണമെങ്കിലും ഉപയോഗിക്കാം. So that is just an insulator. So what we are having is that we are having a metal oxide and then we are having a semiconductor. So just look the difference. So whenever you are looking the capacitor, you are having a metal oxide metal contact, and here you are having only a difference, the metal oxide semiconductor contact. Now you try to, now what you have to do is that you have to take the metal oxide metal, that is the capacitor as the basics, and based upon that you have to find what will be the difference that can be happen whenever you are coming to this structure. So I have explained that I think that this is the topic that we are studying in first 100 slides. But you can see the concept is very simple. In the first 100 slide, we are just discussing about the metal oxide semiconductor contact. Now you see, once again we are going to the capacitor. So here you can see you are having a metal oxide metal contact. Now just recap what you have studied in +2 class. So whenever you are giving some charge, assume that here you are giving some charge, positive charge Q, you are saying that an equivalent negative charge Q will be induced in the other metal plate. So that is the first concept that you have to recap. Whenever you are having a positive charge on one metal plate, you are having negative charge on the other plate. Next concept that you have to remember is charge is deposited. See that the metal may be having a physical structure, something like this. Now, whenever you are giving some charge here, for example, this is the one metal plate and this is another metal plate. This is a contact that you are giving. Okay. Now you can see that the positive charge will be coming here. That is on this side, and the negative charge on this side. Okay. And again, you have to remember that this charge we call it as surface charge. So this is the surface charge, and then you can think about the Gauss law that you have studied. That means the Gauss law simply says that if you are taking a closed loop or closed surface, which will be cover the one plate, which having a charge Q. Now you can find the electric field that is present in the insulator layer. So that will be just given by, that is Q divided by the area. So that is coming, that also you have studied, that is coming from the Gauss law that you have studied. Anyway, this topic is not that much important. I am just saying that in the case of a metal oxide metal, the charge is surface charge and the electric field is confined only within the insulator layer. Okay, but in actual case, you can see that here also there may be some positive charge and there may be some electric field, diverging electric field that is present. Okay, so we are neglecting that one. Okay, now you come, and now I told you that whenever you are giving positive charge here, an equivalent negative charge will be come here. Okay. Now, with that information, you try to attack this structure. So here you can see that you are having a metal, then oxide, and then semiconductor. Only difference is that is coming here in the semiconductor side. So assume that here you are having a charge plus minus Q. That is, just to take this structure, and here you are having minus Q, and assume that the semiconductor is p type. Now you can see that whenever you are giving minus Q, similar to this one, you can see that it will be produce surface charge at this side, the oxide side of the metal. So here you are having negative charge. Now, according to the capacitive theory, or analogy that you are taking from the capacitor, you can see that there must be equivalent positive charge on the other side. So you can see that the p-type semiconductor having large number of positive charge, that is holes. So what happening is that the holes, which are majority carrier, they will be deposited on this side. Okay, so you can see that this structure is exactly similar to this one. There is not that much importance for this configuration. So here you can see that it is simply acting as a capacitor. So whenever you are giving minus charge, here you can see if it is p-type semiconductor material, here you can see that you are having positive charge. And again, you can see it is exactly similar to a capacitor. It is not that much importance. But you think so the same structure, that is p-type semiconductor material, metal and oxide semiconductor. Now assume that here you are having, and here you are having some positive charge. Assume that because it is similar to a capacitor, and you can give positive charge or you can apply positive voltage. Then what happening is that as per the capacitive theory, you can see here there must be positive charge. Okay, now according to the concept of capacitive theory, you can see there must be equivalent or equal number of negative charge on the other side. So you can see the charge cannot be sit inside the semiconductor, because we already find that in this metal we are saying that the charge must be in the surface or near to the surface, something like that. So the same thing that is happening, there's a PN junction diode also. Whenever you are making a PN junction diode, you can see the depletion region is formed only at this interface, not at the center. So exactly similar way, there must be some negative charge that must be on the P side, oxide, P side of the oxide. That means in this region there must be some negative charge. The question is that how this negative charge will be come here, because you already saying that here you are having a p-type semiconductor material, and the electrostatics or the fundamental electrostatics concept says that there must be negative charge on this side, but you can see there is no negative charge present here, but there may be some negative charge that will be present, that will be the minority carrier. Okay, so minority carrier electrons are there, so that can be come here. That is one possibility. Second possibility is that you are having a p-type semiconductor material, and the p-type semiconductor material having positively charged holes which are free to move, and the negatively charged acceptor atoms. Negatively charged acceptor atoms which are not free to move. Okay, so if we remove, or by some force, if you are removing the holes from some region, for example from here, you can see there will be exposed negatively charged acceptor impurities will be there. Now you can see that here you are having positive charge and here you are having negative charge. So these are the two possibilities that can be happen whenever you are applying a positive voltage. So whenever you are applying a positive voltage, positive charge will be here and equivalent negative charge will be produced on this side. And for that, two options are there. First one is that from the minority carrier. But remember that the number of minority carrier at a point or number of carrier at a point is related to the potential. So this is a concept that we have studied in the first module, and we have repeated the same concept in the second and third module. We are already saying that the potential, that is electrostatic potential at a point, and the charge concentration is related. So to that point we can come later. Even if we are saying that the minority carrier is coming at this interface to nullify the positive charge on this side, you can see there must be some voltage at this point. So we have to think about how that voltage will be created. Another method is that this this negative charge can be produced by removing the holes from some small region, and by that there will be a region similar to a depletion region in PN junction diode will be created on this side. That means here you are having negatively charged acceptor impurities. So here you are having positively charged. So these are the two possibilities that will be happen. So depending upon the voltage that you are applying here, you can see sometimes the carriers will be created by depleting the holes. You can neglect the number of free electrons, number of minority carrier which are free electrons at this surface. So whenever there is free electrons, you can see that must be free to move, and so they will be form a surface layer or surface charges. Electron will be surface charges, but you can see their number is very less. So depending upon the voltage that you are applying, you can have these two scenarios. There will be only depletion region, and there can be a negatively charged region on the P side. Okay, so this is a basic principle of MOSFET, metal oxide semiconductor field effect transistor. So in the first 20 slide, we are just discussing about this MOS structure, and not 20, first 100 slide. And there you can see there are a lot of repetitions are there. So you take your own time for going through that, because this is very important. But you can see all the concept that I am explaining is just based upon the concept that you have studied in +2 class. So first you are having metal oxide metal contact, and you assume that you are removing one metal by a semiconductor. We find that depending upon the voltage or the charge you are applying on one of the plates, three things can be happen. So whenever you are applying a voltage or a charge such that it will be induced the majority carrier, you can see it is simply working as a capacitor. Then if you apply a voltage, for example, in this case, you are applying a positive voltage. On the P side, you have to create negative charge, and this will be created by two methods. First one is that a depleting. Depleting means that there is no free charge carrier. And if you are applying very high voltage, you can see the minority carrier, or there will be a large number of free electrons on this side. Okay, so from this one easily you can see what MOSFET is doing. So depending upon the voltage, so I'll be tell what we are having. Just so this is metal contact, which we call it as gate, and then you are having an oxide layer. There is no access from the outside, and then here you are having another terminal that is called a substrate or P. Okay, then you can see that you are applying here. You can control the number of carriers. Okay, now if you are having one contact here and one contact here, which we call it as drain and source, you can see that you can control the current flow between the drain and source based upon the voltage that you are applying. Okay, so this is the basic principle of metal oxide semiconductor field effect transistor. So what I have done is that I have started from the capacitor, and then I have just take that same concept and that I have applied to a MOS structure, and I have shown that you can control the number of carriers, or you can control the current between the contact on the either side of the channel by using a voltage that you're applying on the gate terminal. That means that the voltage that you're applying on the gate terminal controlling the current. So that is the reason we call it as field effect transistor. Okay. So with this, I think that if this concept is clear, I think that with this information, you can go through the first 100 slides without any problem. Okay. So this is a qualitative explanation. Now what we have to do is that our ultimate aim is to find what is the current that is flowing between drain and source for a particular gate voltage. And for that, you can see you have to find out the number of free charges, number of electrons, in this case, the number of electrons that is produced on the channel by this gate voltage. So for that, we have to go through the mathematical concept that you have studied in +2 class and in the first module. And compared to the bipolar junction transistor, this is very simple because this is only an electrostatic problem, EOI, electrostatic. We are just applying the concept that we have studied in electrostatics, or in the first, I think that we are just using the concept that you have studied in +2 class for finding the number of charges. And again, the current carrying mechanism is by the drift mechanism. Okay, so what I'm saying is that only some few concepts that we need from the first module, and all the remaining concepts required to analyze this structure, MOSFET, you have already studied in the +2 class. Okay, so if you have any doubt, we can just go through the slides. Okay, so that is the essence of the metal oxide field effect transistor. And so I'll be just to go through that. These are some cartoons that I have already explained. The cartoon model for the transistor. That means it is a current voltage. So here you can see BJT I am showing. So this is a BJT model. That is the base current is controlling the collector current. But here in the case of field effect transistor, the voltage that you are applying, that is controlling the current between the drain and source. So it is a voltage controlled voltage source. So this you have already studied. This indicates the main difference between these two. BJT is a diffusion mechanism and VI characteristics. But in this FET, what you have to do is that you have to control the drift current mechanism and some concept from the capacitor. Okay, so it is a voltage control device and it is a current control device. And now you can see the BJT or the MOSFET. You can see in almost all the ICs, they are using the MOSFET concept because of the following advantage. It is having high pike intensity, and again you can see it is a voltage control. That means that it is having very low input current, and based upon this reason, you can say that it is having low power dissipation. And again you can see the voltage required is also very small in the case of MOSFET. And so this topic that you have to study, so you just take the second module, that is the PN junction and BJT. That is only take it as a topic that to study or take it as an example for study in the first module. But you can see whenever you are coming to the field effect transfer fourth module, you can see this concept you have to recap or you have to use in the VLSI subject that you will be studied in 5th semester. So this topic is very, very important, and you have to carry over what you have studied here and how the different equations that you are deriving here.
സർ ഈ PDF സാറ് ഗ്രൂപ്പിൽ ഇട്ടായിരുന്നോ?
ഏത് വീഡിയോ?
വീഡിയോ അല്ല, PDF മറ്റേ FET എന്ന് പറഞ്ഞ
ഞാൻ ഇന്നലെ നാളെ ഇട്ടേക്കാം. Okay.
Okay, sir.
Already I have shared the slide for the BJT and BN junction. So this I will be share. Okay.
Okay, sir.
So in field effect transistor, similar to transistor, it is having 3 terminals. One is gate. Instead of base, we are having gate terminal, and then you are having 2 other terminals, source and drain. And from the name itself, you can say what is the meaning. Source means that they will be supply the majority carrier. So remember that they are supplying the majority carrier, and drain will be take the majority carrier. I already told that there is a channel, a small conducting region will be formed on the substrate, what you are calling, by the voltage that you are applying on the gate terminal. For example, this is a gate terminal, and this is the oxide. And then depending upon the voltage, gate voltage that you are applying, you can see there will be a small channel will be produced here. And for connecting to that channel, you are having 2 terminals, that is source and drain. So this is the source terminal, and this is a drain terminal. The source will be supplied majority carrier to the channel. And again, in some device, you can see this will be also available. You can have the connection to the P-type